Yo, what's up, everybody? Welcome back. Today we are working on our little game, and today's topic is trying to get some form of animation rendering. So, for context, this is our little mock-up of the game we have an idea for. It's gonna be this like couch co-op RTS type game where you're gonna have you're gonna have this like little army, and this army is gonna fight some other army. We can pretend they're here facing the other way. We didn't put them in the mock-up yet, but they would be there. And the idea of the game is that you are these like little guys. You're controlling them, and they are collecting berries for their giant slug monster, right? There's a giant slug, they collect the berries, they put the berries in the juicer. The juicer's full of trees right now because we didn't, it's a mock-up, it's good enough, right? We're gonna put the berries in the juicer is gonna make some juice, is gonna feed the slug. When the slug gets like, yum, 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 got some berry juice, yummy, he's going to basically like shit out another man. So he's gonna like, fall out of his butt, come in here, and we're gonna have 4 guys now instead of 3 guys, and they're gonna collect more berries. Wow. Eventually, you run out of berries here. So what do? You cut some paths through the forest, right? Imagine that like at the beginning of the game, there are no trees here. You go, okay, little men, could you please cut down the trees? Let's do some deforestation, please, sir. And then they go and they find some more bushes, they feed the guy, they get more guys, right? You build up your little army. Eventually, you get into like the middle of the world, and your opponent has done the same thing from the other side. And you end up meeting each other, and you're fighting for resources. Eventually you're like, "Oh, there's no more berries, but we need to grow." Right? Everything in the world is about like growth and expansion and getting bigger and better, right? So you start like killing each other, right? Your armies they like collide with each other, and basically based off of like rules, I think we're gonna do it so like if you run into each other facing each other, it's gonna be like 50-50 chance that you kill each other. But if you like attack from the back, then like your probability of winning goes up. So you're kind of beginning to start like controlling your guys, trying to like run around, attack from the back, and use like the paths that you've cut through the forest to kind of like shape the way that the battle will play out, right? Because you could maybe like navigate some guys around the back, trap the guys in between, and then you have to attack them from both sides. They can't face both sides. You win, right? So as you start killing the other guys, the part that we forgot to say is that you're going to put their bodies in the juicer. The guys are like big berries, right? And so your army grows now by consuming blood instead of juice. Yum, 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 right? And so that's kind of like the idea of the game. And so we kind of got our little mock-up. We've kind of like rendered our little character. Hello. There we go. And we've got a little run animation here. Wow, exciting. Look at him go. And so today we want to, try to render this outside of Blender, right? So we've been kind of like using Blender as our kind of staging area to figure out if this idea works, which I think that just by looking at it now, I'm kind of confident that we can like make something this fun. And so we need to bring this into our game. So this is our game. It's not very ready at all, right? Basically, all we've done is we've exported some GLTFs from Blender. We've like loaded our like mesh. We've got like some amount of material parameters on them, right? He's at least like the right color. We haven't done like texturing yet, right? So our like wooden sword and shield are just like blank, but we have something, right? And we've figured out how to like load the armature that's associated with this guy, right? So here we've got a bunch of bones for him, right? And in here when you look at his bones and you run the play, hit the play button with the bones. Let's do this. Right, you can kind of see his bones. They're making a little animation. And so today, and like by making that animation, it like deforms the mesh, and it turns into something that's kind of pleasant to look at. Well, pleasant by some metric of pleasant, right? And so our goal for today is to try to do, at the very least, get the bones moving in the right way, but it would be super cool if we get like the mesh deformed as well. So we'll see how complicated that is. I don't really know. I haven't like looked very carefully at this. So plan of action is to first like just inspect the file that we've exported from Blender and see like what do we have in order to like how the data's somewhere. We got to find it, right? Once we find it, we're gonna like load it and like put it into the app in some way that we like think is reasonable to work with. Then once we like have the data, we have to like do something with the data, like maybe move the bones, maybe, and then eventually tie it back to the mesh. So that's the plan. We'll see where it goes. But that's the plan. Well, that is the plan. We have to satisfy the shareholders. Yeah, we have to grow forever. We have to satisfy the shareholders, or else we'll be in trouble. Okay, so I guess step one would be to look at the exported files. So we have like, this thing gets like automatically exported as part of our build process from like blend file to gltf. So we should have like asset gltf in here. Nice. And we know that we have like names in here that kind of match the Blender name. So like we know that like in our node storage at the top level, there are nodes that are bones, right? So we can kind of like make some guesses here about like, you know, they have like rotations, translations. We're using these parameters right now to position the bones, right? So when we run this guy and we look at this bone view, these bones are positioned by these like translation, rotation, and scale parameters. The bones are kind of like default just pointed straight up, and then we like maneuver them from straight up at the origin to like wherever they're supposed to go, right? So he's got his little feet here, he's got his arms, wow. So I would assume that some animation will probably adjust these parameters somehow. That would be my guess, but we don't really know. We see that like, you know, there's other objects that are mesh objects in here. Animations sounds promising, right? So he's got channels. So it looks like he has like one animation in here, because like this curly brace, if I jump to the other one, it's like, that's the end. So we have one animation who has what looks to be like many channels, like lots and lots and lots of channels. I don't know what a channel is yet, but he's got a lot of them. He's got a name for his like animation, I guess that makes sense, and he has samplers. So we could probably assume, looking at this, that these sampler IDs are saying, please look at these samplers. That would be my guess. I would also guess that these nodes are probably node IDs in like the overall node array. So this node array, like we have bone 1 here, right? Bone 1 is node ID 0. So presumably, like this channel, yes, this channel says apply the stuff that you find at sampler 4 to the rotation of node 0. That would be my guess here. But not really sure. Set fold method equals indent might be nice for getting an overview of the file. Yeah, that's not a bad idea. And then we kind of like, yeah, that's not crazy. Not crazy. So where were we? We were in animations. Channels. Yeah. So we're like, okay, this guy is going to read from sampler 0, node 15. So we go to our samplers, and he's got some sort of input and output and interpolation. So you can do linear interpolation between this and that. Now this, I don't know what this means, okay? And then this is translation. Can we look at like a rotation? So sampler 1 is a rotation, and he has step interpolation. So I don't really know what that means, but we'll maybe look at the GLTF spec and figure that out a little bit. And I think I'm pretty a little bit lost here. We could maybe assume that these guys are pointing to some structure that defines like two translations, right? If this guy is a sampler that is affecting the translation target, you could probably imagine that somewhere he's pointing to like an original location and then a new location, right? That would be my guess. So this 58 and 59, they could be like, samplers down here. That doesn't really sound that interesting. It could be like some of these accessors, right? So like this like 58 and 59 here. This looks like he has like some stuff in him. Who knows? You know, like this is like a vec3 in here. So maybe. So input 58, output 59. Yeah, it could be these. Although I'm missing 58, 59. They do have like different types, which is a little concerning. That doesn't really line up with my guess. But maybe like these views are different. Okay, let's take a look at the GLTF spec, and we'll try to see if we can glean any information from this thing. So maybe we want to look for properties reference, and we are in animation sampler input. Okay, index of an accessor containing keyframe timestamps. The accessor must be of scalar type with floating point components. The values represent time in seconds and strictly increasing values. Okay, and so this is the time. Then output is keyframe output values. Who knows what the fuck that means? Animated values are linearly interpolated between keyframes when targeting a rotation. Slurp should be used. Should in caps means doesn't have to be, right? We read this as they put big bold should, and we read that as okay. It's like when you're at work and your boss is like, "You did a good job," and you're like, "So I could have done a worse job." Right? It's like this should is like, so you're saying I could not do it, right? You're saying one thing, but I'm hearing a very different thing. Um, in POSIX books, should means must. Yeah, that's true. But here they have must. Must means must, and should means don't have to. I would guess. Step animated values remain constant to the output of the first keyframe until the next keyframe. Okay, cool. So that makes sense. So input is time. That's interesting. And output is, I assume that the output here probably type depends on your target, right? So if I'm trying to edit like a rotation, then you would expect a quaternion out of this guy. And if you were editing a translation or a scale, you would assume like vec3s, probably. So like for those of you who have not been following along, you know, because why would you? There are like basically like there's like a binary file sitting over here, and the GLTF kind of has like these like views into this thing, which kind of says like which like segment of bytes should I be looking at, I think. And then there's accessors, which apply like metadata to this view, if I remember correctly. So like yeah, so like this accessor says use buffer view 52, but it's like, you know, this component ID, it's like an integer or something or a float. And there's two of them, and there are two vector threes, right? And then your buffer view is kind of more kind of raw data layout. They're just kind of like this is kind of like where the bytes are. So when they talk about this sampler output, you know, they're kind of saying like, you know, hey, this thing accessor at this you know, whatever index this is has this component type vec4, so this is probably a rotation, right? Okay, can we look at maybe kind of concepts here? Maybe they'll talk about animations in here somewhere. Animations, nice. GLTF supports articulated and scan animation. I don't know what that means. Via keyframe animations of node transforms. Yep. Keyframe data is stored in buffers and referenced in animations using accessors. Cool. All animations are stored in the animations array, and animations define a set of channels and a set of samplers that specify accessors with keyframe data. Cool. Okay, following examples show how expected usage, blah, blah, blah. Okay, channels connect output values of the keyframe animation to a specific node in the hierarchy, so that's our guess. Everything there is lining up with what we said. RFC 2119 defines this. I imagine it reads something along the lines of must mean must, and should mean must. Classic. Target property is an object that identifies which node to animate using its node property, blah, blah, blah. Okay, so this is everything that we guessed, right? Nodes do not contain a mesh with more blah, blah, blah. Okay, I don't care. Within one animation, each target must not be used more than once. Okay, blah, blah, doesn't matter. Okay, each animation sampler defines input output pair. A set of floating point scalar values representing the linear time in seconds, and a set of vectors or scalars representing the animated property. Okay. A set of floating point scalar values. That's probably input. All values are stored in buffer, accessed via accessors, refer to the table below for the output accessors type, blah, blah, blah. Inputs of each sampler are relative to t equals 0, defined at the beginning of the parent animation's entry, before and after the provided input range. Okay, so like what I'm a little bit more confused about is like, sure, we have an input and output, and they define linear time as well as properties, right? But like, what do the values of like what do they mean? So samplers with a given animation may have different inputs. Okay, so if we're like, they're saying like, yo, if you're a translation, you should be a vector 3 of floats. Yep, makes sense. Implementation, like whatever, like who cares? Weights, ooh, yeah, morph targets. So we're gonna kind of be in like this world: translation, rotation, and scale. Implementations must use following equations to decode real floating point value f from a normalized integer c and vice versa. Okay, so that's interesting. I don't understand what that means yet, but we'll maybe get there. Animation sampler's input accessor must have its min and max properties defined. Okay, interesting. What does that mean? Animations with nonlinear time inputs. Okay, who cares? I don't really care. Morph targets. Who cares? Okay, I guess maybe we just start trying to load this data, and then once we like see what the data is, we might have like a better idea of what to do with it. Hand wavy, right? We can also maybe open the blend file as like a reference, right? We have our animation that we made in here, and we can kind of try to like tie whatever we're seeing back to that animation. So in here, maybe we like, how do we do this? We go into pose mode. No, where's our like? I want to see my little keyframes. I mean, they're clearly happening, so why don't I see them? Maybe I have to pose mode, select all. There we go. Here we go. So we should be seeing something that lines up with this. So it would be kind of nice. Maybe we filter for one bone initially, and then we can kind of work our way forwards from there. I think that makes sense. So maybe we look at the animation for what is bone here. I assume that's like, can we like hide this guy? Who gives a fuck about this? Okay. Okay. So bone. This is like his pelvis / spine, and we should be seeing kind of full everything. We should be seeing locations and rotations. And we should be seeing 1, 2, 3, 4, 5 of them. Right? Okay. Let's do that. So I guess this is kind of half finding the animation, half like attempt import of single bone. And let's just kind of look skis. Okay. Can we, how do I fucking set fold method? How do I unset? How do I set fold method? Let me out. Let me out. I guess we'll just reset Vim. I don't remember. Manual? Ah, yeah, that makes sense. Okay, so here is where we load a GLTF, and we like take this GLTF and we like extract some like properties about him that we care about. Like we extract like the nodes and like the mesh data and the materials. Bones are just like objects in this scenario, so objects are just like things that have location, translation, and scale, essentially. So in here, I guess, as we are like walking each joint, we're going to try to extract some animation data about this guy, I guess. Maybe we walk the data first and then like figure out where to put it later. So this is, I guess, not part of the joints though. Like here we are kind of like loading like information about all of the bones, but this is like a separate thing. This is like, how do the bones move? So we have what it was called? It's called like animation, which is not something that we import yet, but we can fix that. I think it's animations. Okay. And that means that clearly we need like an animation. And our animation was something with channels, if I remember correctly. Animation has channels, samplers, name, extensions, extra. So channels, okay, yeah. So we have channels like this, samplers, and name. Okay. Then we need to make whatever these guys are. So our animation channel is gonna be like, I don't know. We'll figure it out. Sup G, what are you cooking today? We're trying to do some animations, baby. We're trying to make our little bones in our app do this. Okay. So what was in the channel again? Sampler target? Wasn't there like in and out? Where was that in and out? Maybe that was in the sampler. Yeah, the sampler had input and output. Okay. So here the things we care about are target, which is what type here? This is a descriptor of the animated property. So here, I think that in the GLTF that we were looking at, zig out, share, character, asset, GLTF. I still don't fully understand how the animation stuff works in Blender, especially if you want to export like multiple animations. I know that there's a way to like create named animations somewhere. Like you can see like this is kind of all under, like if I select all of this stuff, it's under armature action 001. So I assume that I can name this like run, and I can make like another animation like that's like walk, and then I assume that in the animations field of the GLTF, we would start seeing like uh we would start seeing like, what's it called? Like multiple animations that all apply to the same skin with names, and you would probably like filter the GLTF to like pick which one you want to look at, right? So probably eventually we'll be loading this guy and we'll be saying, we know that this asset has a walk animation, a run animation, an idle animation, and like maybe we can like do some blending between them, etc. Yeah, that's when you have to start digging into NL stuff, which just breaks my head because the UX is so bad. Oh yeah. I can see that. Okay. So where were we? We were trying to get the. We have the target, which is a string. No, it's this node and path. So I guess this is an animation target, and that means that we need animation target has node as a usize probably, and path as a string. Maybe this is like an enum. I think that this is allowed. I think that you can do like, I'll have to double check this, but I think this is allowed. Yeah, we'll see. Okay. Cool. I guess we can kind of start here and just see if it parses still. Because that'll give us some clues. So he's mad because there's a division by 0 somewhere. Like, how is this different than before? This is a build error coming from mem.zig? What the fuck? What is it? F reference trace like this. Load GLTF in it. Parse from token source. Okay, so this is a problem with us somehow. It's probably like animation sampler has like a null size or something, and he doesn't like that because it's empty. Yeah. Okay, so that still loads, which is good. That's pretty good. And so can we like maybe just start making sure that like that enum trick was working correctly? So in storage, we want to go like loader GLTF animations. We're gonna look at like we're gonna look at the channels, I guess. And we're gonna say like have animation for this node with this target. And this is gonna be like channel name target node channel target path here. And this is like a tag name because this thing's an enum. Okay. So let's see what that does for us. Okay, so this is promising for sure. So we have animations for node 10, translation rotation scale, node 9, translation rotation scale. Okay, cool. That's kind of hype. That's kind of hype. It's really cool. I didn't like. It's pretty fucking sick that like Zig's JSON parser, you can do like automatic enum to string shit. That's kind of hype, right? Like this animation path. It means that we can like just switch on this thing later. Okay, so we have node path, and then on our it's time to like look at the samplers, I guess. Uh, so the sampler is the thing we care about is input and output, and then interpolation. I guess we probably care about interpolation too. Animation, sampler, interpolation is an enum, and here I guess we just need to be like linear. Step. Cubic spline. All right, fine. And now this guy has like input, which was a usize sampler ID, output, and then interpolation was an animation sampler interpolation. Okay. So if that builds and runs, then we're still chilling. Hype, 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 hype. And now we can start like looking at those things. So channel sampler, did we lose that shit? Channel target node path. Okay, animation channel sampler. Yeah, so did we lose that one? Yes. Okay, so we also didn't uncomment this, so that's gonna change some stuff, probably. So this doesn't parse anymore. Unexpected token. So this is at line 412. Okay, let's take a look at that. Here, sampler target. Oh, because this is a usize. This is a sampler ID, not a sampler itself. Are you making your own game engine? I mean, calling it a game engine feels really strong at this point. You're damn right he's making a game engine. I mean, it's, yeah, like, I think that I'm just trying to game thing tool. Yeah. Yeah, we're just trying to make a game thing tool. Okay. So here now this guy, he has a sampler now, and so now we should be able to look at that sampler. So does that, what are we gonna do with this? Sampler input. So can we look at the accessors, I guess, which I think that we have like helpers for accessor data at this. And this gives me just like the raw data. So this is like the input data, and then we have like the output data. But I guess maybe we don't really care about this right now. I guess maybe we do. I don't know. We'll see. We also have like accessors at this guy. And this guy's going to have some metadata for us, I guess. So maybe let's look at that metadata first. So what do our accessors look like? This. So let's like look at component type, count, and type, I guess. Maybe we just say input is this thing. And output is this thing. Uh-huh. Okay. So like animation for scale. He's like, I have some data here. I have floats, 2 of them. And type is this shit. Can we maybe change the type field here to be like a proper enum? Accessor type here. And then what are our accessor types? How do I see what like the allowed types are? Here. Boom. Boom, 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 boom. So I guess this is like X, C, comma, go to the next one, go, 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 go. Sure. So does that give us like a nicer log here? No, because now when we're actually checking these things now, we should just be going like this is equal to vec3 like this. Nice. So then here we're asserting that the normal accessor type is equal to a number that is a vec3 now. Nice. So simple. This guy needs to be a scalar, I guess. Okay. Is that all of them? Hopefully. I don't think that we're doing this much. If you need a basic rigged object like a bouncy cave with a bone, I can do some cook friend. Yeah, it's okay. We've already got our little guy, so I don't think we need much more. Okay, so for scale here, we've got buffer view, 60, floats, two floats that are scalars. So this is the input. So when we saw in the docs that inputs are essentially like the timestamps in here. And so I guess we're saying like we have two time steps for this scalar. We have two time steps for the scale parameter for this bone. And here are the two vectors that you're going to set those at. Okay, that makes a lot of sense actually. So some of these are like 13, right? So for that's probably for like the bones that have like a lot more going on, right? If we look at why is scrolling going fucking go up and down? Fucking dumbass. Okay, sorry, we're fine. 1, 2, 13 feels like a lot for any of these. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, 13 feels like a lot. And I don't think any individual bone modifies itself on each checkpoint here. So that's a little bit interesting, but maybe we can just trust it. Okay. So I think what I want to do here is I want to filter for a single bone, right? Like just his like pelvis, and then we can like inspect the data for that thing. So I guess when we're loading this thing, we check our nodes should all be populated at this point. So we should be able to look that thing up somehow. I guess we're gonna look at like GLTF nodes at like the animation, I guess the channel target node. And we're gonna say like if the target node name is bone, I guess. I guess if it's not this, we continue. Okay, so now we should only get logs for like one bone. Hype. Okay, so we have node 15 is our root bone of this guy. He has one accessor that for the translation that is happening 13 times, once per frame, I guess. Do we have information about like the interpolation type here? No, maybe we should log that. So maybe we'll put like this. I think it's like channel target in sampler in. Where was that interpolation word? Sampler interpolation here. So it's we don't have that yet probably. Oh, we do. So we should just be able to go sampler.interpolation here. Fuck. Tag name to get the string for the enum. Little compile time reflection. Don't mind me. Okay, so this translation is linear interpolated once per frame in the animation, I guess, but the rotations are linearly interpolated just at like 2 points. Does he even rotate? I feel like it shouldn't. I feel like this root bone is literally just going up and down, but we probably checkpointed the rotation, which is causing it to show up in the animation, probably. And it's quite surprising to me that it's exported every frame here. That seems fucking crazy to me. Right? Like, we know that what we have in this animation is 1, 2, 3, 4, 5 checkpoints for translation, but he's exporting them all, which feels bad, but maybe we just don't question it for now. We won't question it. We won't question it. If we want to come back to this later, we can, but we don't have to if we don't want to. And then, yeah, so this step for rotation and scale, I guess this is kind of indicating that the rotation and scale are the exact same for the whole animation, and then it's just saying, like, I'm going to reset myself at some point, probably. That's my guess. Okay, cool. So let's load the data for this then, and like see if we can interpret it in some way. So I guess we probably switch on the like sampler. It's like the path, right? So if we're like doing a translation adjustment, we're expecting like a very specific thing here, right? I think it said in the specification here that if our thing is a translation, we're supposed to do like a specific thing, right? Where did we see that? Maybe it was in concepts? Yes. So here we are expecting these things, right? So if we're translation, it should be vec3 and float. So we can probably check that. Output accessor component type is equal to float, and the accessor type here is vec3. Okay. So then we can try to load the time steps here. So I guess no matter what, this is going to be, we're assuming that the input accessor type is equal to scalar, I think is what they said. And it depends on the type here, what we end up with. Interesting. Interesting. So I guess maybe we just start with only looking at the thing that we care about. Or like we just look at what we have and figure it out from there. Did we have input accessor here? So he says our inputs are floats, which is height. That means that we don't have to do maybe it's defined down here in the accessor input, input, input. Index of an accessor containing keyframe timestamps must be of scalar type with floating type components. These represent time in seconds. Okay, cool. Okay, so let's load these things. So we have like our accessor data at input accessor or sampler input, I guess. And we need to do some sort of like uh, bytes as slice of F32s. I think makes sense here. So can we just write like time steps here and take a look at those? Uh-huh, uh-huh, uh-huh. What? Okay, cool. So here we're seeing, at what is that, 41 milliseconds, 83 milliseconds, 125 milliseconds, 166. So this is happening, I guess this is probably, dude, what frame rate is this? Is this like fucking, this doesn't look like a multiple of 30. This is, what a strange, our animation speed must be, yeah, that's very strange. Very strange. Maybe it's like configured as PAL or something. I would expect to see like 0.33, 0.66 or something. Oh no, because I guess movies are like 24 frames per second. I guess. Yeah. Okay. So this is at 24 FPS, which is like strange, but sure. We could probably reconfigure this to be whatever we want. Okay. Okay, works for me. Works for me. So cool. Blender's 24 by default can switch to 30 to 60. Yeah, makes sense. Makes sense. So I guess they're targeting movies by default, which is like a totally reasonable default. Okay. Then if we have our translations, we write them down. Okay, so I think that we have to like put this data somewhere. Somewhere. And I guess it belongs in our like storage somehow. When we load this GLTF, we export some stuff from it. What do we say? We say, hey, this is our bones, here's our materials, here's our mesh, and I guess writing down like the animation channels probably makes sense as well. So here we can go like, we're gonna store some animations. And then here we need to like determine what our representation of this thing is gonna be. So I don't know. I don't know at all. I guess. I mean, the way it's laid out in the GLTF file kind of makes sense to some extent, right? You're like, here is the way that I am going to modify some object in the scene over time, right? So I guess us saying like, here's some object ID component, like even just reusing this animation target or animation path seems kind of reasonable. Oops. Right, so here we're going to update one of translational rotation or scale. We're going to update this guy. Here are my time steps. Right? And then we're probably also going to say, maybe we store like translation animation like this. Then we don't store this guy, and then we can just store like, you know, translations. Not crazy. Not crazy. And then as like the animation system, as we run it, just like rips through all of the animations. But I guess like we're not going to just have like some like global animation runner, right? He is going to be running animations for specific objects starting relative to some specific time, right? Which means that this is probably still fine. But like in reality, the workflow here is probably going to be more like I have some object and I know that this object is going to start running now, right? So let me collect all of the animations associated with this object and associated with this object and this animation, right? So we have like, we want object to animation and then animation to channels, right? That's kind of what we want. And then we're probably going to like query this thing, start, then this is going to be like start like running animation is going to have like probably like reference time, right? And maybe like as like a stood time instant or something, right? And the like translations probably scales like, you know, translation scale animation or something. Yeah, that kind of seems reasonable. And then if our storage kind of like, if our like global storage stores these things sequentially, this could be kind of actually like translation start as like a translation ID, translation animation ID or something, right? You could kind of do something like this. That doesn't seem crazy to me, right? So how this is kind of like unknown to me right now, how we're going to do this lookup. I guess our object could just kind of like store inline whether or not he has animations. It's kind of, I guess it's like we're probably at some point we're going to be like, load me this GLTF file, right? And I'm going to ask you probably for like some IDs that are associated with some things, right? So maybe I will pass in like objects that I care about. And I'm going to say like, hey, let me know where like the character armature is, right? Like please tell me where this armature is. And then like maybe there's like armature 1 and armature 2 or something, right? Maybe we're like, we have like some armatures we care about, we have some like meshes that we care about, right? We're like, if we want to like rotate his eyes and stuff, we might say like left eye in here, right? Like tell me these things is probably where this is going to go, which means that this guy is going to return some sort of like, you know, loaded data, right? And this is probably how we tie everything together, right? So in here, we will ask for like run animation, right? That probably makes sense here. So this thing is going to return, we can then say like loaded data animations at 2 would give us like the idle animation, right? Are you going to use GLTF as your internal scene graph format too? No, I don't think so. We're kind of like, we're taking the GLTFs and shoving them into some sort of like intermediate representation. I don't really know what that's going to look like. I'm kind of just making it up as we go. Okay, yeah, so this seems like a reasonable API, right? So then that means that our objects don't, our like object storage doesn't have to tie animation to object. That's like a thing that we do externally, right? We know that this GLTF, when we load it, we know that this run animation is for this armature. We know that that's like information that we have writing the code. Gotta go to sleep. Good night, 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 night. Which means that we don't have to tie anything together, which is kind of hype. This still has to happen. We still have to tie back an object ID to what this animation is targeting, because like this is kind of more like top level knowledge, where this is like specific knowledge, if that makes sense, right? This is going to tie back like translation to leg bone 2, right? And our leg bone too is not something that we're keeping track of externally. Okay, so I think this makes sense. The only thing we're missing here is like the animations here. So I think what we're gonna do is our animation type. This has translations, which is going to be a series of translation animations, rotations, which is going to be a series of rotation animations, and scales. Right? And then when we go and we say, I would like to start my animation, we get this guy back. We then, when we like start him, we rip him relative to some timestamp, and to run the animation, we just rip all the translations, rip all the rotations, rip all the scales. Yeah, that feels like it would work well. I think. I think. We'll see. That feels pretty good. So scale probably is vec3 translation. This is scales. This is rotations. And rotations are quaternions, probably? Yeah. Hype. Hype! That just feels like it works. Okay, so that means up here, we need like we need to store all of those things as well, right? Translation, animations. We need our like rotation animations and our scale animations, I guess. Feels reasonable to me. Okay, so now when we're loading this shit, we like say, hey, here's our translation. And I guess as part of this, we must track all of these things, right? So animations, I guess we're like, here is the first animation for this guy. Let's not get crazier. Let's just like assert that there's only one of these. Animations len is less than or equal to 1. And then we can just kind of, as our output here, throw out an optional animation. Which means that we probably need an animation ID. Okay. Cool. Cool. What's he bitching about? He's bitching about all sorts of stuff. So here we added all of these parameters. So we're kind of just doing like runtime. We're like allocating some fixed amount of memory on initialization and just hoping for the best. I'm just slapping like we're saying we have no more than 100 of anything right now, and my thought is like we are going to know later the sizes of all of these things, right? Every commit, you kind of could figure out what their maximum things are going to be here, because we're going to load all of our models on initialization. Then you can just like query these and like update these numbers later, but I'm not really worried about it right now. Okay, so translation, rotation, and scale. And so this is like translation animation, rotation animation, scale animation. Okay. Hype! What else is mad? This thing is mad because animation here is going to be self animations, items, len -1 if there was one. So if, you know, loader gltf has an animation, then we give him our animation ID like this, probably strong typed as we want it. So to trigger the end run, you have to type run Mr. Skeleton, run. Yeah, exactly. Run Mr. Skeleton, run. Get out of here. What's it piss about? Found void. True. That should fix it. Okay, so this all compiles, which is kind of now we actually have to like do the work. Um, so I guess here we kind of construct our output lists of translations, rotations, and scales. At this point, I don't think we know how many of each of them there are without walking the list once. So I guess we could just do like, we're good. We know we're gonna have less than 100 of them, which is like plenty. Um, sure. Rotations, scales. Okay. So this is kind of like our output for this specific animation. These are not going to be constant. These are going to be variable because we're going to be modifying them. And so if we see a translation, we're going to go like translations append whatever this thing is. So I guess we get like this is our like input data. Our output data here is something like this. We're going to like look at the outputs as F32s. And I can't remember if they like end up being padded or not. I think not. I think they're just inline like 1, 2, 3, 1, 2, 3, 1, 2, 1, 3, 1, 2, 3. But we can check when we loaded translations positions here. We did in fact run these as groups of 3. Yeah. Okay. So we should be able to be like for 0 to output data over 3. We have like start is I times 3, right? We have like end is start plus 3. Then we do like a translation append of this thing. Yes. Except he needs the time steps as well. Sure. Then these time steps have to be allocated on our like long-term allocator, I think. Okay. Target is the node. We need to like get like our node ID out of this guy. So I think that means that we need to write down what our like internal node IDs are for each node that we see. I guess we assume for now that these targets are all going to be bones, which means that all of these joints we'll have like a lookup in this armature builder. Surely. So we can look at like armature builder ID map get, and here I guess this is usize to node ID to object ID, or node ID is usize. Yeah, so this is going to be like target node. Okay. And this is to a node ID, so we're kind of hype. Time steps is going to be like, we probably need to store our allocator here. Yeah, something like this. So we can go like alloc heap arena dupe. We dupe this like input data here because we read this into our scratch allocator, but this is going to be long lived now, so we kind of do something like this. Bump, 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 bump. Okay, that's kind of cool. And then the Translation. Oh, this is like many translations, right? This should be one per time step. Which means that this goes kinda outside the loop. And then here we're going to, do we know how many targets there are? We do. We have this information right now. So we can do like self, alloc, heap, arena. We can use this as a one of these like runtime bounded arrays, and we use output data len over 3 as the length. Yup. Which is, I'm worried that we forgot to write init here. Uh-huh. Okay. Translations. Fuck. T anims, I guess. R anims and S anims feels nicer. Because now we can call this translations for this guy. He doesn't have output data yet, but we can kind of just do this. Bing, bang, boom. Translations now. We put append. Yes. So here, we should have like output data start plus 1, start plus 2. These are the 3 floats. Yeah, there we go. Yeah. So this end isn't needed. This guy's tried. And then here we go like translations are translations, baby. And here, this does not need to be duped because we already put these on the right allocator. So this is going to live forever. Sure. Blaze it, I guess. Does that build? No, because we need to like take these sanums, tandums, and randoms and put them somewhere. So after we kind of work through all of this, we should have them now. Oh, see, this should be tandems. Okay. So then we're like animations, append. Tandem translations is tandems. And here, I think that this was on the scratch allocator, so we dupe it out. Now that we know how long this thing is. Yeah. And we probably do the same for scales and rotations. Just with like the right types. Okay. Does that build? We'll see. Here we say alloc. Here we need to store both a heap and GL allocator. So we're just kind of doing some shuffling and buffling. Okay, bang, bang, boom. Okay, input data, expected const F32. What the fuck is this thing then? What's the problem? What the fuck is this? Unknown. Hello? Surely, right? I'm pretty sure, dude. Oh, found a line 1. Oh, interesting. So this stuff like might not be aligned correctly. Ugh. That's kind of gross. Can we could like mem copy it out, or we could just kind of hope for the best. Do an align cast here. And see if that fucking crashies. It might not, but it might. Probably will. But maybe we'll get lucky. Maybe. Okay. Okay, that's promising. So that like ran at the very least. And so now can we go to main and can we like try to inspect the animation that we got out of this guy? So like somewhere we load our model here And can we go like if model animation? We have some animation. And can we like print this thing? Like hopefully that all kind of works out. So we do have an animation ID here, which is not helpful. We do probably want to look at like storage animations. Like we probably want to call it get animation with the strong type here. Okay, which means that this like storage get animation needs to exist. I'm not like sure how I feel about these accessors. I like the idea of strong typing our indices, but I'm not so sure if I'm happy with like the storage API being like who converts these. I'm not really 100% on that, right? Because like this feels kind of silly, but fuck it, you know? Okay, so we end up with an animation that has one translation, zero rotation, zero scales. Okay, makes sense because we haven't finished yet. So we can probably let's limit it to one bone first for now, and then we can kind of like expand later. Let's skip rotation and scale for now, and let's try to run the translation component of this thing and see if we see anything. So let's say we've attempted import of a single bone. We'll say TX only for translation only. And now we are at, oh man, 01, 06, 42. And we want to like apply single bone translation. I think that's kind of it. Then I guess later we're going to be like the rest, right? Who knows? Who knows where we will go? Okay. So I'm really curious to see if this concept of being like, let's start running this animation now will work. So beep boop, let's like figure out where this is gonna go. I guess like it would make sense that like we would have some like global list of currently running animations somewhere, right? And like every frame, we just rip all of the current running animations relative to their time steps, and like we just check, oh, do we have to advance any of these guys anywhere? I think that makes sense. Which makes me think that we're gonna have some sort of like animation. Calling this thing animation is a little confusing. Now we have like GLTF animation, we have storage animation, then we have like animation. What the fuck does that mean? So maybe we call it animation running animation, where running is like currently executing, not like physically running, which is confusing in the context of animation because you could have a running animation and a walking animation, but fuck it. We'll do this. Running animation.sig. Okay. So this thing is going. I don't think that this should be a type. Maybe this is like animation manager. Ugh, gross. We're not allowed to use the word manager here. That's not allowed. Animation animation runner? Animation runner. Yeah, sure. And he's gonna be like, I have some animations. Executing. And these thing is gonna have like a running animation in here, who's gonna be like, I started at some time, right? And this is my ID, right? So we have like storage, like storage is import storage, and we have animation ID is storage animation ID. Bing, bang, boom. We have probably some sort of like expandable list, but with a runtime known size cap, probably. Right? We can probably just high watermark this. I guess you could argue that like you might end up with like spikes occasionally where like you have more animations running than you like accounted for or encountered in development. But you could just gracefully degrade in that case and set this guy's initial size so you don't have to worry about that. I kind of like that, so kind of do this. In here, we'll just write like a little fix me and be like, unsure if, like, ensure we never hit this cap, or degrade, like, nicely. It would be kind of funny to, like, if you have too many guys running at once, some of them are just T-posing. It's like kind of like a funny degradation. Okay. So surely this guy's just gonna have like a step, right? Right, surely. And he's probably gonna look at like the storage as well. He's surely gonna have to like look at app state and do something with it. Who knows what? Um, and so he, I guess, is going to what? He's gonna go like for each animation, you know, running anim. We're going to like get the animation. Right? Then he's gonna like rip all the translations. And is this just... Yeah, sure. I guess we need to store where we are? Question mark? No, because we know now. We need to know now. So I guess we advance through animation until last time. So here we probably store like last step was like some instant, right? We're like we at some point in time before now we had done something, right? Which means that probably we're gonna like defer self last step is equal now. So we're gonna like advance our animation until last time. So we're gonna say like our rel time is now since last step, but this is gonna be in nanoseconds. So we do this as a float, and then we do like rel time divide equals stood time nanoseconds per second. Nice. Hell yeah. And so now we know this is for each animation. Ooh. Okay. This is interesting. So this is the relative time. This is not useful. Yeah, this does not feel useful. What we do want is we want relative time to the start of the animation, right? So let's look at the like now since running anim start, and I guess we probably also want like now relative, and we probably want like last relative, right? That's kind of what it seems like. So now we can determine what step we were on before and what step we're on now, and if we have to do anything. Yes. So we are going to do something that's like find like let me think. So we have like an animation, we have a thing at like 1 second, we have a thing at 2 seconds, right? We want to do something if we went from here to here, right? So probably, I mean, or if we went from here to here, right? both of these are going to end up doing something. So here we want to find if the last index that we are greater than, and here on the on the now side we want to also find that and check if they're different. So last index less than, and here we're going to have timestamps and time, like timestamp, like needle or haystack needle. This probably exists somewhere in the standard library, but fuck it, that's not that hard. So for haystack, we have value or time, like timestamp idx. This is going to return a usize, I guess. If timestamp is greater than, if needle is greater than or equal to timestamp, if needle is less than timestamp, yes, return index saturating sub 1, probably. And then if we make it to the end, then we return the length, I guess. Probably. Okay. I'm like not confident in this at all. So if we have like, you know, we have some floating points 1, 2, 3, and 4. Right? We're kind of expecting that we pass in like test vals 0 and we get 0. Right? We're kind of expecting like this. We're expecting that we pass in 5 and we get you know, we're expecting that we get like test vals len here, right? We're expecting that we pass in like 1 and we get, you know, we pass in 1. What we're expecting, we're hoping we get 1 back, right? If we're like directly on the point. Last index less than. Yeah, less than or equal, I guess. Less than or equal. Okay. And if we pass in, you know, 0.99, we get 0. And if we pass in 1.99, we get 1. If we pass in 2.01, we get 2 or something. 0. This is also 0. This is 1. Oh, what fuck? My dumbass brain. But dude, I'm putting these in the wrong order. 0.99, 1.99, 2.01. Okay. So 0.99, we get 0. 1.99, we also get 0 because there is no thing there. 2.0901, we get 1. And I guess we're kind of hoping that our animations always have an initial point of 0, or else we don't know what to do, right? Which is reasonable. But we might want to like assert that thing. Probably on like start. Right? So we're gonna be like, hey, yo, could you please Here is the time. And could you start running this animation? And at this point, I guess we will check that the storage animation, probably on parse is a better place to do that assertion, huh? Probably. Um, yeah. Then we need to do our like nice degradation. So I guess we just say like if self animations items len is equal to self animations capacity, we're like probably a warning. Too many animations, and then we just do like just kind of fuck off, I guess. That seems kind of reasonable. That seems fine to me. Okay, so we did want to go back and we wanted to make sure that on load that we assert that the first index is, or the first time step is like close to 0. Otherwise, we don't know what the fuck we're doing. So std debug assert here that input data 0 is, the absolute value of this thing is like less than 1e negative 7 or something, right? Like just make sure that it's kind of close. Make an attempt, please, sir. Okay, cool. So advance through animation until last time. Oh, let's run this test, I guess. So Zig build test probably doesn't fucking exist right now. So let's add that. Add test. And presumably it's gonna be kind of like the same shit here. And then here we're gonna be like, add run artifact. Nice. So we're gonna run the unit tests, and then we are going to even go as far as to attach those to some test step. Like this, and then like we'd go like test step depend on, run UTs is this. So it's like something like this. Here, our unit tests are probably going to depend on a bunch of shit, so we're going to do, like, oopsies. Pub function add deps, like, to some executable, to some module, I guess. Sure, fuck it, and then it's just kind of like this, and then here we're like we have all these words that we need access to, so I guess this becomes like depth tracker, and then here he's like add these dependencies from myself, I guess, right? And then this is just like self dot boom 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 boom, and then all of these dependencies end up kind of like in the like here somehow. It's like blap, 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 blap. And then all of these guys kind of end up here with like types of modules. So it's like delete word, go to the end, put a colon, and write stud build module, comma, delete the line, bop, 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 bop. Okay, and then here it's like return, I guess, boom, like this, slappy, slappy, lap, lap, lap. And then in here, we do another macro where it's like delete around word, put a dot, go to the end, replace with a comma, go, 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 go. Sure. Yeah, nice. Okay. So then here we go like step tracker, step tracker init with the build. We go like depth tracker, add depths to the exe. And now we can do the same thing with the unit tests. Thank God, dude. Zig build test. So now this is gonna like not run our test probably because like it's not referenced by the root module, but that's okay. That's fixable. We just need to get there first. So here we're like, if we're test stood testing ref all decals recursive this, and then in our whatever the fuck we were just writing animation runner in here, can we just like try like return error, uh-oh, like fuck you, let's make sure that we fail. Hopefully we see that now. If not, we probably have to do another ref all decals somewhere. Fuck. Maybe in Zig we're not importing animation runner. Yeah, that's probably it. We hadn't made it that far yet. Still no? What if we do this? There we go. That helped. This guy's mad because like what? Here we need to write some ampersands all over the place. Then he's like, I expected these to be mutable for no fucking reason, so we'll write const here. That's fine by me. Here he's like, you didn't fucking do that shit again because I'm, it didn't line up with the rest of them, so I just didn't write an ampersand. Okay, so our tests are failed. Expected 1 found 0 at 103. Not 103, I'm a liar, at 60. So this one. We're like, I want to check that, this is 0. That's true. That is just true. Okay, so looks like this is behaving as expected, which is kind of hype. So now we can start actually using this to do something. I don't know what yet, so we're going to look at like last relative value. We're going to be like last t, I guess, for like translation is going to be like tandem time steps. Okay. Last index less than or equal to last rel. Okay. Like now t is going to be the same, but with now rel, but like you could do this as like last rel onwards and then add last rel back so that you don't have to search the whole array again. And then you could just check if now t is not equal to last t. We have some work to do. Sure. Sure, okay. So I guess we apply a translation that is the difference between the two. Did we actually look at the translations ever? I assume that they're like relative to the base. So I assume that we should be doing like, storage objects at like this animation target. Uh-huh. Get object pointer, probably. Uh-huh. Arguably. Yeah, this is probably fine. This is fine. Objects, get, throw a little ampersand on here. This thing should be an object ID. So then over here, we're like, get me an object pointer. We have the object. We say the object translation. Plus equals something. Tandem translations at now t minus tandem translations last t. Yeah. Yeah. Maybe. Maybe. I don't know, man. And then we probably have to like automatically loop this. So I guess we can kind of come back to that. It would be nice not to have to come back to it though. So can we? How do we know the length of this thing? Do we just look at the last value? Uh, right. Surely it probably like loops here, right? At tandem time steps len -1. And then here we probably do like like mod time is like tandem, you know, I don't know, man. Last rel like mod the last time, right? Last rel mod, I guess, and then like now mod is like now rel mod the last time, and then here we use like last rel mod everywhere, I guess. That's like a maybe. I'm not like 100% sure that won't work. I guess we do have to do something with this thing, right? We probably have to like actually like instantiate the animation runner. So uh this thing does need an init function, huh? And here, I guess, he returns an animation runner. And here he takes an allocator, surely. And here he's like, last step is equal to undefined. Probably, that's fine. As long as like the first step is called before any animations are added, which is not true. So we will just put a now in here. What language are you using most before Zig? I was using a lot of Rust before, a lot of C++, a little bit of C, some Python, some JavaScript, but I would say like I'm probably most familiar with Rust and C++ before this. Um, but I don't think it, you know, I think Zig's pretty easy to pick up, especially if you're in like another low level language. Okay. So how many of these things are we going to support? I guess 100, and then we'll come back and fix this for now. I've heard good things about Zig. I love it. It's great. I'm a big fan. It works the way I expect it to, which is hype. It's the bar for me is like doesn't piss me off, and it doesn't piss me off, which is kind of sick. Okay, so here we need to, you know, make some thing here, and he wants like stood time instant now, right? I guess we'll say like app start is equal to this, and then here we're gonna put app start in here. And then can we just like immediately start running this thing? So we like load our model and we go like animation runner start at app start this animation. Yeah, fuck it. Sure. Then on each frame, we just fucking step that shit with our storage. And now Yeah. Yeah. No field name animation renderer. Fine. Fine. I'll put an S on it, bitch. Fuck you. No field name animation. I fucking just fixed this. Oh, it's over here too. Like this. This is ID. True. Last rel, expected use size found F32 because, yeah, I don't know what the fuck I'm doing this last T. Maybe I should just have better fucking names here because all these names are shit. Thank God the types didn't match up. Like, you know, whatever. And let's look at the bones. That's not bad. That's not fucking bad. Look, he's running. I think, is he drifting downwards? He's definitely drifting. He's definitely drifting. Bye. But that's definitely close. So run, Mr. Skeleton, run. He ran away. He got away. He got away from us. Yeah. So the question is how do we trigger like a reset here? I guess we probably want, like, if now t is equal to 0, we probably want to do something intelligent here, like go backwards by the entire range. But that is what we're doing here, kinda, right? Right? It feels like what we're doing. It seems like you can't just, like, set an arbitrary local translation, right? Can you? What happens if we just do this? I guess as long as we're not modifying the local translation of any bones ever, it's not crazy unreasonable. Maybe that's fine for now. Fuck it. Sure. Sure. I'm also realizing now that, like, we're kind of modifying, like, the source bone object. It seems like we're probably going to have to, in the future, support, like, instantiating, like, copying bones for each object instantiation or something. I don't really know how it's gonna work. You're gonna have some sort of, like, root bone object, and then, like, yeah, there's gonna be something weird. Like, you're gonna have like 100 guys all using the same skeleton, but at like different points in some animation blend or something. I don't know. We'll figure that out later. Right now, we're just modifying the like only bone that we have for this character, which is like fine because we only have one guy on the screen. But that is something that we're gonna have to think about later. Okay. So I would say apply single bone translation. Hell fucking yeah. We're not interpolating or anything. But that's fine for now. Let's maybe try to apply all bone translations. You know, gotta catch them all. So let's go back in here, and I think before we, in our load GLTF, when we load the bones, we are kind of filtering for some specific guy somewhere here. Okay, so if we take this off, that like filter, we should start seeing all the bones start translating, but not rotating. And I think that maybe the rest of these guys are mostly rotations. So there's a chance that that's the problem here. So let's kind of throw in some rotations here and just see what fucking happens. Okay. So presumably it's going to look similar to this thing, right? We're going to expect to see floats, but they're going to be vec4s because they're quaternions now. Our output data is still some sort of like floating point representation of these guys. We are going to be probably appending quaternions to these things now, right? Rotations here. And this is now going to be length over 4, not length over 3. And this is going to have a 4 here. 1, 2, 3 here. I think that we're going to have to be a little bit more clever with this. We're going to have, I think it's X, Y, Z, W. So I think it's like X, Y, Z, W, real, we called it here. And then we invert our negative X axis because like LHS, left-handed coordinate system to right-handed coordinate system. Which one are we? We're left. Uh-huh. I guess probably we should be doing this here as well, to be honest. And we just didn't notice because our translations are mostly vertical. Okay, then we're like randoms. Append this shit, and we're gonna be like randoms items. And this guy's mad because he's like, this thing doesn't fit right, and also this guy's constant. He should be variable if we're modifying him, which makes sense. Then this is actually rotations here, not randoms. Bing, bang, boom. Expected equaternion, found a bunch of them. It should be a bunch of them. So we make that an array. This thing is also going to be an array later. Okay, does that compile? Does it run? Hype, 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 hype. We don't actually do anything with rotations yet, but that should be easy to do now. That should be easy. So we have our animation runner, and he is going to rip all the rotations as well, right? And oopsies. It looks like there's going to be a lot of duplication here, right? Like all of this stuff is kind of the same, right? All of that's the same. Fix me all the same as translations. All the same until here. And then even here, it's kind of like, we'll just say like whole block, very similar to translation. And then here, it's like, this is the only part that changes. So it's like random target, our like local rotation is going to be random rotations at like now t, and then we're actually just like stepping here. We should be interpolating, right? So this is not just like now is different than last. We should be seeing like how far into last we are relative to now, right? But fuck it. Let's just see if this has like an effect. We're going to see it be very jumpy, but you know, at least it should do something. Come the fuck on, dude! Come on! That looks awesome! That looks so sick. And in fact, I think like stylistically, I actually kind of like the choppiness. I think that's very funny. I think that like there's like some like endearingness to that. Right? The fact that his arm is not running at 60 FPS, but it's running at some like fucked up frame rate. It's and like his legs, it's actually like kind of fucking cute. Like the way it's just, yeah, that's sick. That is awesome. Okay, so I guess we do the same thing with scale, but we're not applying any scale to our animations right now, so it doesn't matter. Eventually we are going to have to apply this to the mesh as well. But I do not think that that is going to be something that is easy to do in the next 15 minutes, which is how much time we would have if we were targeting our 4 o'clock end time. So I think we call it there. That's pretty good progress. It's kind of sick that like it just all kind of worked. Right? It's just like everything we do, we just kind of we thought about it a little bit. We did whatever seemed reasonable at each point, and like, what did we end up with? It feels like what we ended up is like sane in terms of like code, right? We have this like animation runner who just says like, hey, I'm going to start some animation with this animation ID. I'm going to rip all of the translations that are associated with this animation, all of the rotations associated with this animation, and I'm going to like do those things, right? Our animation storage is like a little bit fucked up, but I think kind of reasonable. So we have like all of these like animations that have like time steps as well as like translations or time steps with rotations or time steps with scales. These are all attached to one big animation. So this animation goes like, here are my translations, here are my rotations, here are my scales. Arguably, you could probably fold this down somehow, right? Like the fact that like translation and scale animation are like the same is kind of interesting in some way, shape, or form. But yeah, we have like this like one animation structure. We say here they all kind of just have like timestamps of stuff that's gonna happen in them. And then we just like parse the GLTF. We find those pieces and we put them in the right spots and we just run it. Seems sick, dude. I'm quite happy with that. Quite happy with that. The code is like fine and it looks fucking awesome. All right, yeah. So thanks for watching, guys. If you like what we saw, we stream most days around 12:30 Pacific time to 4 o'clock Pacific time. It is 3:45 now, so you should expect to see us online 3.5 hours ago to now most days. If you can't catch us every day, but you want to keep up with the project, there's like a YouTube link in the Twitch description where we kind of like keep our projects organized into playlists. So you should be able to like go back and catch up on this project. We try to make it so that like all the important progress where like new features is kind of like tracked in those YouTube VODs, but sometimes we're doing stuff that's like investigation or like cleaning up like a minor bug from yesterday or like code cleanup or refactoring or testing and all that type of stuff. It's like it's not really like a titleable, thumbnailable, YouTubeable thing, right? But that's still worth doing. So if you want to catch that stuff, you have to catch it live in the like 12:30 to 2 segment typically, or we archive the like happy hour VODs in Patreon or on YouTube members or on Twitch subs. So if you want to support and get access to the that stuff as well, if we can't catch it live, support on wherever it makes sense. Please consider supporting. This content will end someday, but that day is determined by a dollar value in my bank account, right? So the more money we manage to scrape together, but while doing this, the longer this stuff exists. I think that's all the plugging we got to do. YouTube, peace out, and Twitch, let's find someone to raid.